welcome Ajit sir for this podcast. This is a kind of a podcast where I'm trying to demystify what is it all about when you are delivering something in the world of AI through an academic world. Because trust me, that's the platform where every great individuals just evolved over a course of time. And if you see the way which we are architecting the solution, it's all the same old way in which we are architecting it, but yet we are just understanding what is that little tiny chunks of pieces that can be improvised over a course of time. Because now we are just trying to mimic a brain on a burning box. And right now, I think Ajit sir can give a lot of insights for you folks in order to understand what is this tech all about. So thank you so much, sir, for giving this podcast. It means a lot.
Okay, thank you, Vishwas, and thank you for inviting me as well. So I think that I'll start off with your first question about academia and research and where AI is going effectively, which is what it is coming to. So I think AI is in a very unique position because it has very close links to academia. And you can see this, like, for example, the founders of DeepMind and many of the people, they come from a research or academia background. And you see this sort of much more interconnection between industry and academia, specifically when it comes to AI. So for example, if you're doing mechanical engineering or chemical engineering, there is a certain kind of a trajectory, but with AI, it's a lot more closer. And I think the reason is because of the nature of AI, meaning that it's a very, very rapidly evolving field. And people look at AI as a monolithic thing, but there are kind of many subcategories within that. And if you look at it from a job perspective, then the classic AI role, this has been covered in your podcast a few times, it's kind of looking at data engineering, data science, and DevOps effectively. Yes. So that's the pipeline. So you have the data engineer, the data scientist, and DevOps. And essentially, when someone like me is more in the middle, i.e. the data science side, that is building algorithms, but also has very close links to the other two, i.e. the data engineer, who is effectively working in some kind of a Spark typically architecture, and then the DevOps person who is putting things in containers and deploying containers and sort of into production using Kubernetes or something like that. So effectively, this is the pipeline. And then there is also the role in terms of how you view the person. So for example, if you look at a classic sprint agile architecture, then people are building something and they are building something with the intention of putting something in production, correct? So effectively you have a problem, you have a product, you have a deliverable, you have a build, and everything is sort of iterating towards that build. And as a data scientist, you are sort of in that mix along with everybody else, and in the part of the sprint in the Monday morning things or everyday morning kind of stuff, stand-ups and so on. But I think that the trajectory of research is quite different. Yes. So for example, someone like me tends to spend a lot more time on understanding how algorithms are going, where algorithms are going. And that is where, in a sense, that this is another difference between that. So, I mean, is a data scientist, is the research exactly fitting into this agile paradigm? Yes, I mean, I can spend a lot of time doing a number of hypotheses, and the result is none of them work. Yes, and this is not something you want to come back and tell your team, tell your product manager, tell your company that this is you spend a lot of time and it hasn't actually produced anything, but this is science effectively. Yes, because this is what you have to do. You have hypotheses with something and then you have to try it out. And this again is a kind of a strange sort of an interaction between the AI role and the traditional role. So this is how I see AI and kind of industry coming together, and that I think will continue. And it depends on which area you are in. So for example, if you look at areas which I tend to work with much more around digital twins, cybersecurity, bioinformatics, all of them are very close to sort of doing much more research on the AI side. Does that help?
Yeah, that's true. That's true. Because we are trying to build something which is more mimicking the brain, but yet we are yet to understand what is it all about. So my first question is like, what if we build the AI to the fullest potential? What will be the definition of it? And what will that AI be in a form factor like? What will it look like? I just wanted to understand that.
So first of all, I think the idea of mimicking the brain is aware into a lot of literature, but it sort of is not the best analogy. Partly because if you look at the history of AI, that did start off by mimicking the brain. Yes, if you look at the older kind of the 1970s, 1980s of AI before it went to effectively the AI winter. So the goal since about 2010 isn't exactly mimicking the brain, although it does have neurons, and the neurons are modeled on physical brain neurons. The goal is much more simpler. The goal is more what is called connectivist AI, meaning that you are looking at trying to mimic some activation functions using data and algorithms, and you have lots of data, lots of compute, and lots of these simple steps, and together they are supposed to build something which would add a level of insight. Now I use the word insight as opposed to intelligence because in many ways it is not intelligence. It is a problem solving in a very specific vertical domain. And so it is not the general intelligence. And in that sense, I think the analogy of the brain tends to be a little bit misleading. It tends to get people on the science fiction bandwagon. And often it kind of takes it away from there. However, having said that, I think that I am very optimistic that we will come to some very, very interesting things now going forward. So I'm reading a book at the moment from MIT, and it's a book about the sort of the where AGI is going, and you will be surprised to see the sort of interplay within different things. Yes, so if you think about how to model the brain of a mouse, you can look at it in different ways. You can actually have a physical mouse and slice the brain and try to understand how it works, or you could model that brain using some nanotechnology and try to see how this works within that. So all of these ideas are sort of evolving itself, and the embodiment of AGI may not be as we see it, meaning that if you think about the Wright brothers analogy, yes, prior to the Wright brothers, everybody was trying to fly, making birds, yes, so trying to do something which went up and down and then hoping that it would fly, but the solution turned out to be having something which was flat, like a wing which was not moving, and yet it was able to fly. And this, I think, is what in many cases we would have to sort of step back on what we think is sort of what we see today, and try to look at the future and try to think that that's what it would look like. So this is why I tend to distinguish these things. But I'm a big believer that we are going to see this sort of singularity. I don't like to use the word singularity because it is unfortunately kind of taken over by a number of things. The first problem with the word singularity is essentially used by Kurzweil in this context. And this is great, except the only problem I have with that is it tends to put a date around it. And that's the problem, because I think that while that is sort of interesting, it's not likely to be sort of in the 2160 type of situation, which is what they are expecting to say. What's more interesting is that the principle is correct. Yes, the principle is correct. That where it is going, that's what matters. So, for example, Alan Turing also spoke about, in his original paper, spoke about the year 2000. When you would have the Turing complete machine. We do not have the Turing complete machine yet, but the principle is correct. It is going in that direction. Maybe sometime later it would happen. And so I think that this is why I like the idea of where this is going, but not a date around it. This is what I wanted to say. Yeah.
I have been learning a lot on sustainable AI because today, I think what we might architect for the tomorrow's world, I feel it's somewhere going more towards the sustainable AI. But I feel that world has learned a lot about AI system. But the only thing is we just are waiting for that one piece of an hardware which can do a magical compute over a course of time. And it's an inevitable thing. It can fail over a course of time. Yes, we can say that, hey, the AI made the fault, not me. I had written the algorithm and everything. But what are we supposed to unlearn and relearn in this process of building something which is more sustainable, which is called as a sustainable AI? Because I feel that there is a lot that has been learned, but there is some things that are yet to be unlearned from our side. So what do you think about the way that we are building a sustainable AI for the future that we are thinking for the tomorrow's world?
So what is your definition of sustainable AI?
So, so the one which really makes a decision according to all the required categories and all the required strategies applied on it, and everything goes in hand, and AI doesn't make any sort of
Right.
a
So
blunder.
you're speaking about ethical AI and all those things
Yes,
combined together.
yes.
Okay, fine. Yeah. So I think that one of the sort of thoughts around that is the problem we are seeing with the current AI is twofold. Um, First of all, it is data driven, and the second thing, it is black box, and both are related to each other. Yes. So to a large extent, the success of the current techniques is based on the effectively the backpropagation deep learning architecture from 2010 onwards, and which was dominating in the last decade. So from 2010 to 2020, that was the case. And especially after 2015, 2016, when you had GANs and reinforcement learning and stuff like that, so those architectures are evolving themselves. So there is the basic multi-layer perceptron architecture. From there, you had convolution neural networks, which again was a huge jump in terms of that. And then there was LSTM, and then there was the transformer-based architectures. And now we have GPT-3, and we have other heavy architectures. So even in a very short time, these things are evolving very, very fast. Yes, but there are two characteristics to that. The first one is that they are data driven, meaning that you need a lot of data to model a problem. If you do not have the data, you cannot model the problem. And the second thing is that by virtue of the algorithm itself, the decision is made through a series of weights in neurons, which is hard to explain to a third party. And that leaves you with the explainability problem. So if you sort of take that into stride, then the first observation is that it is often not malicious, meaning that these things can be malicious and will be malicious, and there will be state actors who will take advantage of algorithms. Leaving all of that aside, assuming that you are in a democracy which has a government or a basic rule of law, which is designed to help its citizens, then I think the challenge is that the architecture of the algorithms will mean that you are confined to certain types of problems where you have data, and you are also confined to making a decision, not being able to explain that decision. Now, that means there are two ways to solve this problem when you break it down like that. The first one is that there are better ways to explain a decision, which is what the whole explainability AI situation is going. And the second way is that there will be other forms of algorithms which are not and which are not based on the core architecture of taking lots of data to model something and building up this bottom-up hierarchy of features and sort of representation learning, which is called that. So when you look at it like that, then I think the real solution is twofold. First of all, the current deep learning architectures will continue, and they're doing very, very well, clearly. I mean, if you look at GPT-3, for all its drawbacks of all the transformer-based models. They are doing amazing stuff, yes, and they will continue to do that. They will continue to evolve. The explainability will be one part of it. The other part of it that we will see a whole bunch of new architectures. I tend to spend a lot of time around some of the Bayesian work, looking at combining Bayesians with deep learning, and this is already happening with probabilistic probabilistic TensorFlow probability library. For example, if you look at the work of Judea Pearl, what he talks about, the book of why, as what he calls about it. So this is all about explaining actually the action of AI as opposed to looking at causation instead of just correlation. Yes, so mostly we are looking at correlation at the moment. We're not doing causal AI. So trying to explain causal AI, and those techniques will be different, and those techniques will possibly be an important part going forward.
What is it all about when we are architecting an AI tomorrow? Because the world right now is somehow moved to the low code and the no code platform. So I just wanted to realize, like, how far are we really achieve and state of the art AI tomorrow? Like, how are we going to achieve that when we are architecting AI in the tomorrow's world? Because it's all low code and no code that we are moving towards. So how are we architecting it towards that?
Well, low code and no code are essentially paradigms or ways to implement something faster. Yes, and this is a normal behavior of any system. Yes, because at the moment it is very hard and very expensive to build AI systems, not just in terms of the complexity, but in terms of the salaries and so on and so forth. So normally you will always see that there will be some technological developments to make things faster and cheaper and quicker and scalable and stuff like that. And low code fits nicely into that. And it's going to be a very important part of architecting things going forward, especially in terms of empowering end users. I think that is what is important, because so the way I see low code is a little bit different than most other people. So I'm old enough to remember case tools. Yes, I mean, this is something very, very, I mean, maybe time you were born, I don't know. But case tools were there in the late kind of 80s, 90s sort of situation, early 90s. And the idea was that you effectively had the same situation with relational database skills and so on and so forth. And they were quite expensive and quite complicated. So the idea was that you had the system which builds systems. Yes, you had a case tools which would then magically produce all the code, which didn't happen exactly because it wasn't exactly how things built up. And those sort of purely tools which we just effectively are used just to replace just write code typically do not work, because they tend to produce something which is more standardized and not differentiated and so on. However, the principle of making things easier was very valid, and it will continue to be valid. So in that sense, low code and no code are important strategies. But I see low code and no code in the context of combining it with larger backend transformer-based models. So for example, if you combine the idea of low code and no code with the large GPT-3 type models, yes, so the background work is done through a very large, because any large transformer-based model effectively is a very simple interface, but a very large bit of work done behind it through either crawling or understanding the whole world, so to speak. Yes, so if you look at any of those transformer-based architecture, they are effectively crawling as much as possible, sometimes the whole web, to build a structure. And once they have done that structure, they can do magical things, write code, for example, and so on. So the point is, if you combine the low code interface with the backend, which is having this heavy work done for you, I think you can do some amazing stuff, and very powerful stuff as well. Meaning that you can do a lot by making the things very easy and simple for people to do. The backend complexity is done through the large transformer-based models.
Yeah, that's true. But like, on a scale of 1 to 10, I really wanted to ask this to all the academicians. I generally ask this to all the academicians. So on a scale of 1 to 10, how much is the truth and how much is the discovery of that is yet to be left? Because I feel that AI is still growing and it will just grow over a course of time. And I just wanted to know how much have we learned and how much are we yet to discover in the world of AI? Because we still don't know which is the most critical part in an AI architecture today, because it's all complexities that are delighted by like something like, hey, there is an MLOps and an AI ops here. So let's just throw the model on these pipelines and start working how to deploy at the scale. But when you think of a self-driving car, it basically focuses on how to deploy the models at the scale. And also, how are we architecting a huge set of training models together, and how are we making sure that the car really actuates at the right point? Because we are now trying to move more towards the level 5 autonomy, because I feel somehow we have achieved level 3, but like level 4, level 5 is still a challenging one. So what is the most critical part when we are thinking about what should be yet to be discovered in an AI system that we are trying to build, and what's the critical part in an AI system that we are architecting today? The two questions in one.
Right. So your question has to be broken down into sub-questions, yes, because at one point you're talking about MLOps, at one point you're talking about level 3, level 5 autonomy in self-driving cars, and at other points you're also talking about AI in general, the trajectory of AI in general. So my take on this is that these things are actually, so if you kind of look at it from the MLOps perspective, yes, the MLOps is, we at Oxford have been looking at MLOps since about, in my course, about 3 years ago, which is quite new. I mean, nowadays everybody's talking about MLOps, but we were talking about MLOps for a while. The reason is because I think MLOps is, if you look at large companies, that is how MLOps has, that it's almost a default. Yes, I mean, it's not, I mean, nowadays, if you look at people who do a typical kind of a Coursera course or something like this, they then look at, they kind of learn a bit of Python, they understand Python, and then they come to a job and they realize that there is something, there's a whole world which is not quite taught to them. Because then there is a sort of the data engineering, the data DevOps and things like that, yes. So when you look at it like that, then I think that MLOps is a natural evolution. And from there, you can think about the sort of container orchestration and so on and so forth. So that's just a delivery pipeline. There is nothing magical in my world about MLOps. I mean, people get very excited about it, but it's delivery pipeline. Yes. Now, what you're talking about autonomous vehicles is you're trying to understand the level of autonomy within AI, and that's a different problem. That I think is a problem where you are progressively trusting AI to do more and more things, and the balance between the trust with AI versus the management of AI, and that it is manifested in the autonomous vehicles argument, because that's the sort of thing people understand most. But it could be with anything in the future. Yes, so it could be, to what extent would you trust your doctor? Yes, if you come to an A&E or a hospital, imagine that you never met any person. Yes, you effectively started to have this interaction with these humanoid things, and they continue to take you, and they continue to say that, okay, this is the procedure you got to do, this is your MRI, this is what you do, and so on and so forth. At what extent are you prepared to go through this process without having human intervention? Yes, so this is the sort of level of autonomy. So level of autonomy is sort of manifested in the self-driving car problem, but it is a more general problem. Is a more general way of saying that level of autonomy is to the extent with which you are going to trust AI. And this again will be an ongoing thing. And in that sense, there is no real answer to your sort of 1 to 10 thing, because like I said, the level of autonomy is a more complex question. The MLOps is a much more straightforward architect deployment question. The level of autonomy is something where I think people are going to start to have this discussion into everything they do as more and more AI comes into their life. As to what extent are you prepared to trust it entirely without having human, which is the same problem, which is the same question effectively when you have an autonomous vehicle. I mean, I have actually sat in an autonomous vehicle, not driven into one, but sort of, it's a spooky feeling because you have somebody who is driving a car, but they are hands off the car. Yes, so their hands are not on the wheel of the car. And the car moves by itself. The wheel moves by itself, and the car moves autonomously in that regard. So this is where I think that question is more complex. So there's no easy answer to that.
So how much are we yet to discover for an AI?
No, there's no easy answer to that. I cannot. It's not something.
Yeah.
I think the question is not sort of. Yeah. That's why I said the question not framed in it's not a question you can frame in 1 to 10 arguments.
Yeah, but like we are talking about deployment at scale, but what about the nature of the data set that we are going to see for the tomorrow? Because I don't feel that the scale at which we are rapidly making sure that the data grows in the data center is still going to remain the same. Everything is going to change, and the data is going to be collected in lot of numbers. Like everything becomes a parameter, everything has its own monetization aspects that is covered. So I wanted to know how far are we going to achieve a state-of-the-art data collection model that we are just talking about, because we are talking about data meshes, we are talking about a lot of things. So how is the nature of the data set going to be for the tomorrow's world with respect to today's world, or in the future, how is it going to be different?
I actually think that the world of data in the future will not be very different because everybody is aware of the value of data and everybody is trying to collect as much data as they possibly can. But just having that data isn't necessarily value in itself. So you can collect lots of data unless you are Google, unless you have a real kind of way to monetize it, whether it's Google or Facebook or something. There's not a lot of those companies will be able to do that at that level. With that. So if you are a small manufacturing company, yes, data is important. It helps you to understand your process. And I think you will, it's advisable to collect as much of it as you possibly can. And similarly, if you are a retailer, data is important because it helps you to understand your customers, and it's necessary to get hold of as much as you possibly can. So I think all of those models will remain the same. The question is that, I guess, the question is, because your insights at the moment are tied very closely to the data, and that's where the gap is, because there are some processes where you simply do not have data. There are some processes where you have data, but it has dramatically changed. So for example, if you look at what is happening with Zillow at the moment, this whole thing about buying and selling houses, and how rapidly that algorithm has, there could be many reasons for this. I'm not saying that one of the reasons is supposed to be that things have very rapidly changed, which includes some carbon initiatives, COVID, and so on and so forth. The past does not equal the future. If the past does not equal the future, then I think that when there's a discontinuous event, then I think you also need to look at whether that data is going to tell you what you want to know, or whether the ground truth has changed. So I think that data is part of the problem. I know it is very sort of fashionable to talk about the data side of it, but to me that's a given, because yes, data is useful, more data is useful, and more data will give you better results. But the contra question is that there are many cases where you do not have data, many cases you cannot have data, in many cases you have data which has dramatically changed. So I think that this idea of sort of data is interesting, and it makes good slogans like data is the next oil and that type of stuff. This is very, very tired way of kind of thinking about things, mainly because I think everybody will do that. I mean, it isn't, if you're Google or Facebook or something like this, you have a very different view of the world. If you're everybody else, it's a different view of the world. So yeah.
Yeah, it's all the data drift and a model drift that we are just studying, but
Cool.
it's just going to change over a course of time. So my last question is like, how far are we achieved the state-of-the-art AGI that is present today? Like we still have virtual assistants, we still have a lot of things which are getting updated, but how have we ever achieved any of the state of the art algorithm, or else have we yet to achieve the state of the art AGI, which we are just desiring to build? What is it all about when we are having this sort of a journey in building such kind of an architecture for the tomorrow's world?
Yeah, sure. So I think the word AGI in my context, how I define it, is general intelligence. Yes. So when you look at what we have typically is narrow intelligence. Yes, narrow intelligence meaning that you have AI which can do one thing very well, but it can't do another thing using the same model or architecture. And the closest thing which can do multiple things using the same architecture today is the idea of the GPT-3 or any of those large transformer-based models. And I use the word GPT-3 just because it's easier for people to kind of relate to. But any of those large models which can do multiple things. So, for example, they can write code or they can write music. Yes, because they have learned so much about so many different things. They can do multiple tasks with a certain level of competence. Yes, so somebody who writes code has possibly learned as much code as possible from GitHub, and then tries to do that. Somebody who an algorithm which tries to write music has learned the same thing, but by kind of scrolling lots and lots of sound, audio clips, or whatever it is, and then try to understand that. So I think that is where I see the closest manifestation of that. I also see a lot of work being done around reinforcement learning, especially what DeepMind has been doing very recently. I wouldn't call it AGI as such, because it sort of, but it would be leaning towards that because it has one modular architecture which can do many things, predict the weather in the next 2 hours and do play, for example, AlphaGo. So all of those things could be done through those sort of architectures within that. But the real manifestation of AGI, as most people understand it, is much more the sort of the scenario which you see in the movie Terminator. Yes, so you have the sort of the Terminator come into the world, and there he is, and then he goes off and sort of starts his goal of whatever his goal is, which in this case is to kill something or something like that. But it is able to function in a human world in an autonomous way, and that is easy to understand, but of course almost impossible to achieve with that. The caveat here is that whether that would look like that, whether it would look like humanoid. This is the thing. I mean, if you achieve something which does that kind of functioning into multiple architecture, multiple human functions, does it have to look humanoid? Does it have to be embodied? And if it doesn't have to be embodied, then I think we are already on that way towards the GPT-3 type of architectures, because then you are starting to have one architecture being able to do multiple things, and it may not be a physical human looking thing. It may be able to kind of reside into a robot, and it might give the semblance of a humanity just for people to be familiar with it. But its core is not the physical. Its core is the model, which is capable of learning or doing multiple things. So this is how I see AGI. I think that it is, like I said to you in one of the early parts, I see the general trend in that direction. I just don't think that there is a date around it yet, and I think that that's where people get sort of that's in fact the sort of the limitations of many of these sort of singularity like discussions and so on, because then you start to have a date, then you start to have groups of people trying to have their own things, then you have something like a university where you start to try to teach people, then it becomes a business model. That's the problem. Yes, I mean that's the problem with it. So it's not a business model. It's more about sort of what is possible, agnostic of sort of us pushing it in that direction. And I think that so I believe it will happen, but not in a particular time date.
Yeah. Thank you so much, sir.
Cool.
Thank you so
Perfect.
much for such great insights. And I think the future students of mine, if you're listening it anytime, I don't care, but like just get this insights right, because this probably might help you in a lot of ways. And Ajit sir, thank you so much for such
Thank you
great
very much.
insights.
Thank you. And also, I like your posting, what you're doing with all the diagrams and things like this. I saw some of your posting on LinkedIn is quite impressive, and thank you for that. So I did notice that as well. Some of the things you posted about the Azure architectures and things like this, I think they were very cool. Yeah.
Thank you so much, sir.
Definitely.
Thank you so
Thanks.
much.